Hello and welcome to New Scientist Weekly, your fix of the most essential and intriguing science stories of the week. I'm Penny Sarche.
And I'm Chelsea White. This week we'll be looking at the extraordinary megadrought in the southwest US and how it's affecting the vital Colorado River. And we've also got hot news on the latest SI units, some scientific names for very large measurements.
We'll also be discussing the outcomes from the COP27 Climate Summit, as well as learning the science behind a tasty one-pot hack for making macaroni cheese. But first, I just wanted to kick us off with a clip of Dawn Chorus that New Scientist journalist Graham Lawton recorded on a reporting trip to Uganda last week. Wasn't that marvellous? We'll be hearing from Graham later in the show on the logistically difficult topic of how to move an elephant.
And we're joined in the pod today by reporters Alex Wilkins and Madeline Cuff. Hi.
Hello.
Hello. Let's kick things off then with the exceptional megadrought that's ongoing in the southwestern US. New Scientist's American team have been diving deep into this topic over the past few months as part of a special series of articles. And Chelsea, your feature on how the drought is affecting the Colorado River is in the latest issue of our magazine out this week. So can you tell us about the river and what's happening right now?
Yeah, so the Southwest has been in a drought for 22 years. It's the worst drought in 1,200 years.
Wow.
And the extreme length of it has tipped it over into what's called a mega drought. So this has had lots of effects throughout the region, impacting the amount of water people can use in cities and for farming. And it's left the Colorado River in a crisis. You know, the Colorado is massive. It's the river that cut the Grand Canyon millions of years ago. But now 40 million people from several states, from native tribes and in Mexico, all rely on it for water. And it's drying up. You know, it's been years since the Colorado River naturally ran all the way to the Gulf of Mexico. Sort of, classically rivers touch the sea. So that's a sign we're in trouble.
Yeah.
And then the two major reservoirs on the river, Lake Powell and Lake Mead, which are the two biggest reservoirs in America, are at historic lows. They're both so low that they're in danger of not being able to produce power from their hydroelectric dams, which would mean, trouble for the Western grid. And it's such a problem that the federal government declared water shortages for the first time in history, starting last year.
So this is so extreme, isn't it? How did we end up here and what led to the shortages?
Well, it started a long time ago, back with the first agreements that divvied up the Colorado among 7 states, which is called the Colorado River Compact. It was signed 100 years ago in 1922. And the water flow estimates that were used at the time came from data on the recent history of the river. But even as far back as the 1920s, scientists were ringing alarm bells. Those years of data that were used were an exceptionally wet period called a North American pluvial. And they warned that if we continued using as much water as the compact allowed, we would be in trouble. And, we are. One of the researchers I spoke to reminded me that the collection of policies that are known today as the Law of the River were written to allow development in the Western US. And they worked. Cities grew, Las Vegas, Phoenix, industries flourished, and all those people now still legitimately need water to get by. But at this point, it's time for something to change.
Yeah, so these are huge cities, vast numbers of people depending on a river that actually could never sustain them. So what can be done and can we save the Colorado River?
Well, that's a good question. It's the question I set out to answer. I heard from hydrologists and ecologists about several ideas. So, first, there's an effort to reconnect the Colorado River to the ocean by periodically releasing water in what are called pulse flows. So, the largest of these happened in 2014, and smaller ones have happened since. And they have revitalized some of the river delta. Willow and cotton trees are coming back, and there's even beavers returned to the area.
Oh, that almost sounds idyllic. How do we manage, that's great for nature, but how do we also manage the water so that there's enough for all of the people who really need it?
Yeah. So, one of the things we know about climate change is that weather patterns will likely become more extreme. So, even though we're in a mega drought, there could be periods of extreme rainfall and flooding. And one idea is to capture that excess floodwater and put it back into the underground aquifers to store it where it can't evaporate as quickly. So, the Colorado Basin loses about 12% of its water to evaporation, and most of that happens at the reservoirs. And there's another idea, kind of a bigger, more contentious one. It's a proposal to eliminate one of the reservoirs altogether. It's a plan called Fill Mead First, which calls for drawing down the water in Lake Powell and eventually redirecting the river around the reservoir and cutting out the dam so that it can naturally replenish some groundwater as it travels south.
It's kind of counterintuitive because in the UK, we've had drought, not on quite the same scale, but we've been talking about, well, actually, we need more reservoirs to make the most of those really wet winters we're now getting.
Right.
But even if they take such sort of drastic action, is that likely to be enough as the climate continues to get warmer?
I mean, it's tough to know. What we know for sure is that the region is drying. The climate projections suggest that the drought will last at least until 2030. And because of the reduced snowpack in the mountains, the river's flow could be reduced by as much as 55% by the end of the century.
Wow.
So, when it comes down to it, we are just going to have to reduce the amount of water we take out of the system. Several of the agreements that govern the use of Colorado River water expire in 2026. So, the new agreements are going to have to take into account this, sort of stark situation we find ourselves in. But between then and now, we also just have to conserve. So, along those lines, the US federal government is planning to use some of the money from the landmark Inflation Reduction Act that was passed earlier this year to pay farmers and cities and Native American tribes to voluntarily cut back on their water use.
And that's something that the US team has explored in some of the other articles in this series.
Yeah, our reporter Grace Wade wrote a piece on the behavioral psychology behind getting people to use less water and the efforts of cities in the West, such as those in Nevada, to curb water use. They're outlawing, the watering of decorative lawns and vegetation that's around office parks or road medians. And then our reporter James Deneen also wrote a few pieces exploring the history of megadroughts throughout the world and the way that climate change and La Nina have combined to cause this megadrought. We also have a few pieces on how drought may become the new normal. A few of the researchers I spoke to for my feature mentioned that indeed this may not simply be a very long drought, but it could be the beginning of aridification for the region.
Thanks, Chels. You can read all the articles in the Teams' Parched Earth series on the US megadrought at newscientist.com/megadrought, and we'll put a link to that in our show notes. Next up, we've got news that there are some new scientific names for numbers, specifically the numbers that we use to measure things. Alex, what's the story?
Yeah, so last week in Paris was the annual meeting of the General Conference on Weights and Measures. A bit of a wordy title, but they are the international body that decides how all physical measurements are defined and named as part of the International System of Units, or SI units for short. So on the agenda was a proposal to give names to prefixes for measurements that have more than 27 zeros, that is 10 to the 27 before or after the decimal point.
27 zeros.
I know, yeah, it's a mind-bogglingly large number or small number, and we will never encounter them in everyday life. Those numbers which passed the vote are Rona and Keta for very large numbers, and Ronto and Quecto for the very small ones.
I really love these names. I want a pair of cats named Rana and Quetta.
That's a great idea. If any listeners do that, please send us your pictures.
Yeah, of course.
So before we get into what is the point of them, can you remind us what prefixes are and how we use them?
Yeah, so prefixes aren't that familiar to people in everyday life, but you use them all the time. If you've bought a desktop computer at any time in the last 2 to 3 years, there's a pretty good chance it will have terabytes of storage space. The beginning of that word, tera, is an SI prefix, and it means that there are a million bytes, or 10 to the 12, 10 with 12 zeros, in a terabyte. Now, in the SI system, there are prefixes for much larger and smaller numbers than a terabyte. The largest prefix, which is for numbers with as many as 24 zeros, is called yotta, as in a yottabyte. Or if it's 24 zeros after decimal point, so very, very small numbers, it's yocto, as in a yoctometer.
Great, okay. So why, if we've already got 24 zeros, why do we need the new names, the 27 zeros?
Yeah, so they're obviously very big, but real-world changes sort of force the hand of the CGPM. So when yotta and its smaller cousin zeta, so that's 10 to the 21 zeros, were introduced about 2 decades ago in 1991, there were barely any uses for them. But in that time, the internet has absolutely ballooned. Now, the total amount of information is projected to hit 175 zettabytes by 2025, so they're actually using these prefixes now. Now, that's still some way off a yottabyte, and obviously even further off a ronabyte or a ketabyte. But the SI scientists always like to be early with these things. So they say that adopting a standard now will ensure that alternative prefixes don't get too widely used and deeply embedded in the scientific literature.
I guess that makes sense. Are there any other uses from these, do you think, apart from sort of big data?
So there's not any immediately obvious uses. The scientist who came up with the proposal, Dr. Richard Brown at the National Physical Laboratory, which is the UK's Measurement Standard Centre, suggested that Ronto and Quecto could have uses in radio astronomy, for example, measuring the cosmic microwave background, which is very, very weak in terms of the power when we measure it on Earth.
That's interesting, but astronomers have been measuring the cosmic microwave background for ages. So what do they think about that? Do they think we need these?
Yeah, so I did ask an astronomer who works with this stuff all the time, and he said that scientists sort of tend to define their own units, which are more useful in terms of the things they're looking at. For example, astronomers, when looking at the cosmic microwave background, already use their own unit called the Jansky, which is non-SI, but they needed something to call it, and it just so happened that made sense for them.
The Jansky. I love it. So how did they come up with these funny prefix names like Ronto and Quetta?
Yeah, so they do seem a bit random, but they actually follow quite a strict formula. So R and Q were the only letters left in the English alphabet that hadn't been used by either other prefixes or other SI units. Then the middle of the words were loosely translated from the Greek or Latin term for how many times you need to raise 1,000 to the power of to get to the numbers. And then the endings were just because large prefixes always end in A and small prefixes always end in O.
Fun. And is this it for the new names?
Probably for at least a couple of decades. Dr. Brown told me he thinks this will probably see out his retirement.
We wanted to take some time out to tell you about our very special Black Friday New Scientist subscription deal. It's our biggest discount of the year.
That's right. For just £99 or $99 US, you can get a whole year's unlimited access to all our articles on newscientist.com and in our app too.
And as an added bonus, you'll also get digital access to our Essential Guide series, free online events from world-class scientists and experts, our weekly Editor's Highlights newsletter exclusive to subscribers, and access to free accredited courses from the New Scientist Academy.
That's a lot for just £99 or $99, but hurry, the offer ends on Friday the 2nd of December. Go to newscientist.com/Black Friday or click the link in our show notes.
We also have a message for our listeners who are business leaders or policymakers. New Scientist is launching a product specifically for business people that will challenge, inspire, and connect curious minds at the intersection of science, business, and society.
If you're a senior business leader or policymaker and you use New Scientist for your work or to keep across what opportunities science presents for business, please take a few minutes to fill out our survey and help us shape this exciting new product.
New Scientist Business will offer insights and information across critical industries, as well as networking and recruitment opportunities, and a first look at the latest innovations. Visit newscientist.com/B2B survey to participate in our survey. Next up, we've got some comfort food for you, and a science-based way to make it more easily. Penny caught up with our resident cooking expert, Sam Wong, on a hack for the classic dish, macaroni and cheese.
Hi Sam, you're here to tell us how we've all been making mac and cheese wrong and also some of the science behind a one-pot hack that makes it much easier to make.
Yes, that's right. So I've been looking into the role that starch plays when you make a cheese sauce, and I recently learned this cool trick that means that, you don't have to make a roux at the beginning, which just saves a lot of the faff.
Right, so yeah, remind me about roux, because I have to say I never feel more like chefy than when I'm putting one together, but it can be really fiddly and a bit of a pain. Why is it so often like an essential first step to making a kind of traditional sauce?
Yeah, so a roux, if you haven't made this before, in a bechamel sauce or something like that, is when you start by melting butter and then you whisk in some flour. You have to cook the flour for a few minutes and then you add the milk slowly, gradually whisking all the time. So it's sort of quite a laborious way of making a sauce. But it's really important because the starch in the flour is what thickens the sauce. So when those starch granules heat up in water or flour, then they swell up and they burst and they release all these starch molecules, which come in two different kinds, amylose and amylopectin, but they're both sort of these long chains of carbohydrates that sort of get tangled together and form a loose matrix. And that's what makes the liquid more viscous.
And so then why, when you're making sort of a fatty sauce, especially a cheese sauce, is it important that you sort of release all of this from the starch before you then add the cheese, for example?
Yeah, so cheese has got a little bit of water in it, but it's also got quite a bit of fat. And of course, when you disrupt the structure of the cheese, then the fat and the water will tend to separate. It's also got proteins, so this protein called casein. And when you melt the cheese, then the casein and the calcium form these sort of links, or the calcium forms links between the casein protein molecules, rather. That's what forms the kind of stringy chains in melted cheese. And of course, you don't really want too much of that in a cheese sauce because it just makes the sauce sort of stringy instead of sort of smooth and creamy.
Okay, I see. So what's your cheat then to get around having to do this?
Well, so flour isn't the only source of starch, of course. So pasta contains a lot of starch, and when you cook it, then a lot of this starch comes out into the water. So instead of making a flour roux, what you can do is simply cook the pasta in milk and then stir cheese into the same pot.
So I have to say, I'm a little skeptical because it sounds like, one of these newfangled internet hacks that maybe doesn't actually taste all that good.
I learned this trick from a book called Shelf Love, which is by Yota Motolenghi and Noor Murad, and it's a really good book. Their version is like a Middle Eastern take on mac and cheese, but it's it's not actually that different to quite a well-established technique, which is when you're making pasta sauces, for example, cacio e pepe, the Italian version of pasta with cheese sauce. You often use a bit of the water that you cook the pasta in, add it to the sauce, and it helps the cheese emulsify with the oil or butter or whatever else you've got in the sauce. So it works well, I can tell you.
Great. And so what does it taste like? Does it taste the same?
It tastes sort of cheesier and less floury. So I thought it was really delicious. So the version in that book is great, but I've put a recipe for a sort of more traditional version of mac and cheese using the same technique in the magazine.
Great, thanks, Sam. We'll link to your full article on the science of that recipe and the recipe itself in our show notes.
Okay, as we've been covering on the podcast in the last few episodes, the last few weeks saw delegates descend on the COP27 climate summit in Sharm el-Sheikh, Egypt. Environment reporter Madeline Cuff was there, and she's here with us now to discuss what came out of it. Hi, Maddie.
Hello. Yes, I'm back in the UK after a couple of weeks in Sharm el-Sheikh. It was a long couple of weeks in the desert. It was probably quite a difficult context to hold a climate summit in. Obviously, we've got Russia's war in Ukraine in the background, which has prompted countries to exploit more fossil fuel reserves, and the political attention was probably more focused on the US midterm elections and the G20 in Bali. So that all kind of made for quite a difficult mix to come together for this summit.
Yeah, so what was the atmosphere there like? If I'm right, the final agreement was very late, wasn't it?
Yes, so the negotiations at these things always drag on way past the deadline. They never finish at Friday at 6 p.m. as they're supposed to. But this year was particularly tense. There were genuine fears, and the first time that I've really seen this, that the talks could completely collapse at the last minute. And they dragged all the way through Saturday into Saturday night and finally managed to come to some sort of agreement at 5 a.m. local time on Sunday morning, by which time I was back in the UK.
I was watching the scramble on Twitter as all environment journalists were forced to get on the plane before the agreement had been reached. I did see, generally speaking, there's been sort of two strong reactions to the summit this year. There's a lot of happiness and triumph about the progress made on climate justice and compensating the most vulnerable nations for the damage that they're already seeing. But I've also seen plenty of people declaring it a flop because there was no clear progress on cutting emissions or ditching fossil fuels.
Yeah, I think probably mixed bag is the best description for this COP. So as you say, there were essentially two key strands up for debate. So there was this fight for a dedicated loss and damage fund. And then also there was the push to go further on mitigation, which is cutting emissions faster this decade. And that's what will keep this 1.5 degrees temperature target alive. So on the first point on loss and damage, countries did agree a way forward. They agreed to establish a fund that will dish out cash to vulnerable nations hit by the impacts of climate change. And that's really significant. It's something that poorer countries have been pushing for decades. But on the mitigation side of things, the progress wasn't so good. The final cover text, which is known as the Sharm el-Sheikh Implementation Plan, it didn't go further really than what was agreed last year on things like phasing out fossil fuels, and it didn't really push countries to get on with cutting their emissions faster this decade in line with 1.5 degrees. So a lot of particularly richer countries left the summit pretty unhappy with the outcome. The EU's climate envoy Frans Timmermans said the final deal did nothing to address the, quote, yawning gap between climate science and climate policy. And the UK's COP26 president, Alok Sharma, said it left the 1.5 degree target on life support.
I think that victory on loss and damage is huge, isn't it? And people are keen that it doesn't sort of get diminished. But without drastically cutting our emissions, is it fair to say that, it's actually going to be impossible to compensate everyone for all of the damage that's coming from climate change unless we take real action on the carbon emissions that we're emitting?
Absolutely. I mean, Frans Timmermans said at the summit that cutting emissions and loss and damage were two sides of the same coin, i.e. you could kind of have to do both. And poorer nations would argue that the loss and damage that they're suffering from climate impacts is already being felt right now. This is an immediate problem for them. You only have to look at what's happened in Pakistan over the summer to kind of see that writ large. But you're right, of course, the costs of compensation for climate impacts will only spiral as climate change advances. So in a way, there's an argument to say that this loss and damage agreement could actually be the ultimate incentive for countries to push harder on emissions cuts. Otherwise, they'll just watch that bill spiral ever upwards.
Right. So where do we go from here?
Well, as ever with these things, there's still a lot more to talk about. So COP28 is already scheduled to take place in Dubai next year. And that's when countries will really start to grapple with how this loss and damage fund might work. So how much money might be needed, which countries should pay in. That's expected to be a bit of a battle because countries like the US are expected to refuse to contribute to the new fund unless countries like China do. So that's going to create some tensions. There's also a big push to get petrostates and big oil and gas companies to cough up. The argument goes that they have helped very much to cause this crisis and so should really dip their hands in their pockets to find some cash to help out the people suffering the consequences. But that could be a pretty awkward dynamic given that next year's summit is being hosted by the United Arab Emirates, which is one of the world's largest oil producers. And there might be a bit of a broader question to ask here that people are starting to really think about what these COP summits are for now that we've got the Paris Agreement up and running. Why do we need these big annual get-togethers in remote countries? And why did this summit focus so little on cutting emissions? And what can we do to encourage countries to do more on cutting emissions and there be less of the kind of arm twisting and more enthusiasm for going faster to get to net zero? So I think those are some really kind of big picture questions that need to start to be addressed over the next 12 months before we all head to Dubai.
Lastly this week, we've got an interview extract for you featuring Gladys Kalima-Zikusoka, a Ugandan wildlife vet and the founder of Conservation Through Public Health, a pioneering charity that looks at the health and well-being of local people as key to conserving animals. She started her career by training as a vet in the UK, working with cats and dogs and the like. But when she first returned to Uganda to work at the Uganda Wildlife Education Centre, she was tasked with the unusual job of moving elephants from places where they were in trouble to more suitable locations. In this clip, she tells Graham Lawton how she went about the task of moving 2 elephants to Uganda's Queen Elizabeth National Park and the difficulty of getting one in the right position before reversing their anaesthesia.
It's a big undertaking, but you have to first modify the container that you're moving them in because they have to move when they're standing up. All animals have to move when they're awake. Otherwise, they can't be under anesthesia for that long. So we got a shipping container, raised the roof so they could hang out their trunk because the normal shipping containers are the only thing that are strong enough to handle an elephant that's awake. Everything else would just bash.
Right.
And then it involved darting them from a helicopter up above. Getting to them and making sure that they're, they have to be lying the right way. And then after you put a collar on the one that you want to collar, make sure that they're tied up before you reverse them so that you can push them up a ramp. We normally use a conveyor belt into the container. And then once they're in, you have to give the reversal. Then they stand up in 2 minutes.
Right.
And then they're ready to move. So it's all like you rush in, give the reversal, close the door, and they get up. Because otherwise you'll be squashed immediately. And you die immediately. So it's not easy. But then in the end you end up having, in Kenya we moved 5 elephants at once. In Uganda it was 2. But we just put in 2 different trucks because they were very big matriarchs. Well, one of them was a matriarch. We found out in the end, but And then we took them it was a long journey, 15 hours, to Queen Elizabeth. I mean, once they're inside, they're very good. They're a good anesthetic risk. Right. They're not like giraffes, which are much more sensitive, and you have to just do things much faster. But with elephants, they're pretty good. They can even stay down for hours.
For 15 hours? They don't kick up a fuss inside the container?
They do try and kick up a fuss. All you do is give a light sedative.
Right.
I mean, with animals, once the truck is moving, they settle down. It's only when you stop that they start kicking around. But once it's moving at a fairly high speed, they don't really mind. It's soothing, I guess, just like it is with people.
So this is an amazing introduction to your first real job, moving elephants.
I know, could you believe it?
I know.
It was not what I expected from, cats and dogs.
That's all for this week. Thanks for listening, and thanks to our guests, Sam Wong, Madeline Cuff, and Alex Wilkins.
Don't forget to subscribe to our show wherever you get your podcasts so you don't miss an episode. And you can find out even more about the most important and exciting science news by subscribing to newscientist.com. Don't forget our big Black Friday discount available until the 2nd of December. Until next time, goodbye.
Bye.
Bye.
This podcast is produced by OG Podcasts. Find out more at ogpodcasts.co.uk.